This video describes general topics related to planning sampling activities, fieldwork, safety at work, and quality assurance. Sampling activities always begin by finding out the aim of the study. No matter what the research matrix, water, air, soil, or waste, the basic principles of sampling activities are always the same. The measures should be carefully planned and apply the right methods to help achieve the desired outcome. The quality of the samples and the measurements should be high, and they should represent the site at the time of sampling. Work should be done safely and subject to permits. The results should be analyzed, processed, and interpreted well so that conclusions drawn portray the status of the site accurately. Although the actual sampling in the field does not usually take very long, it is always preceded by planning and preparation. A well-made plan guides the entire process from fieldwork to the interpretation of the results and the conclusions drawn from them. The earlier in the process a mistake is made, the more it affects the outcome, and the harder it is to fix the issue later. Whatever the research matrix, you need to consider what is relevant in terms of the aims. There is no sense in doing too much, because that will increase costs and the time spent on the study. The obtained results should be representative, but also resource-wise. When planning, you need to know the research premises, purpose and aim, after which the plan can be carried out. The required information should only be collected from reliable sources. The properties and history of the target area should also be examined. The history of use will generally tell you a great deal about the area. At best, old studies can also provide previous results that can be used to help with new research. The properties of the target substances should also be examined during planning. Chemical and physical properties provide preliminary information about where the substances have migrated to, how they behave in the environment, and how they should be studied. Each site and substance should always be examined individually. Different substances behave very differently in different environments. Before choosing the final study points and starting fieldwork, it is also a good idea to make a field visit to the target site. Maps and aerial photographs may be outdated, and many changes can occur even in a short period of time that can have significant effects on the study. After the preliminary surveys, a final sampling plan is prepared to describe all the steps to be taken. Sampling areas and points should also be planned on a map, which is included in the sampling plan. The points should also be named and numbered clearly, and the markings should be kept the same throughout the research chain. Safety at work is an important part of sampling and all fieldwork. The work must not cause a health hazard or an accident risk to the sampler or outsiders. The sampling team must have at least one person with first aid training. Promptly available first aid can save lives in an emergency. Working alone is therefore never recommended. Work and high visibility clothing and dressing for the weather is also important. The required safety equipment, such as helmets, safety shoes, and life jackets, must also be worn when necessary. Being aware of the health risks of substances is important, particularly when working with hazardous substances. If there's a risk of exposure, you should always wear a respirator or similar. Taking care of safety at work is always more important than strict conformity with the plans. If the safety of work cannot be guaranteed, the work should not be done. Research quality should also be ensured as part of planning and fieldwork. Representativeness should always be considered in light of the aim and the sites. The reliability of samples can be improved with quality control samples such as parallel and baseline samples. Parallel samples control each other. For example, if there are major differences between the results of 3 samples taken from the same point, we know that an error has occurred in the sampling or the analysis. A baseline sample in water sampling, for example, is otherwise processed in exactly the same way as the other samples, but pure water only is added to the sample container in the field. This allows for the examination of potential sources of error in the sampling, sample transportation, and sample analysis. The methods and equipment used must be suitable and reliable for the substances and matrix under study. Many sampling and analysis methods are standardized, meaning that a standard provides clear, current instructions for them. The uncertainty factors of measuring instruments, such as identifying uncertainties of measurement and eliminating identified sources of error, also improves the reliability of the results. The equipment used, such as the meters, should also be calibrated correctly and regularly. The sampler should know the applicability of the methods and equipment that use and how to use them appropriately. When assuring the quality of sampling, you should make sure that, for instance, the fixation chemicals, sample containers, sampling equipment, and other supplies used in sampling are clean and fit for use. The fieldwork situation should be documented in the manner described in the plan. General observations to record are the weather and temperature at the time of sampling, and naturally any observations in the field that may affect the results. Any deviations from the sampling plan should also be carefully recorded in the fieldwork report. Photographs taken while working in the field also help with documentation. You may later notice things in the photographs that you have not considered in the field. Some samples should also be fixated if necessary to ensure the reliability of the results. In general, samples should also be protected from light and temperature variations. The samples are sent to the analyzing laboratory together with the required information, such as the required analysis and sample descriptions. The laboratory will deliver the results of the analysis, after which they can be examined and conclusions drawn. After the actual fieldwork, the equipment used should be cleaned and maintained so that they are ready for use the next time. Successful sampling and fieldwork involve multiple steps, providing an outcome which produces high-quality results representing the state of the site. All this is planned in advance, and the plan should be followed while working. Careful documentation and reporting finish off high-quality sampling. High-quality, safe, and representative fieldwork involves much more than just a visit to the site. A field visit is often preceded by several hours of planning and preparation to make the best possible observations of the site in order to draw reliable conclusions.